You just boarded humanity's first interstellar arc, and the hatch sealed behind you. While somewhere back on Earth, a press release describes this moment as the dawn of a new era for our species. What that press release fails to mention is that you will never see another planet, and neither will your children, and neither will their children after them. 10,000 people now travel toward a star 40 light years away at 10% the speed of light, which means the math works out to 400 years of travel time. You're not a colonist, you're a seed, and seeds don't get to see what grows from them. The TED Talks love showing artist renderings of cylinder habitats with forests and waterfalls and children playing in zero-gravity parks. What they leave out is the 15 generations born and dying inside a sealed tube, the genetic bottlenecks requiring breeding programs to manage, and the psychological research showing that no isolated human population has maintained stability for even a fraction of this timeline. This is the fine print on generation ships, and by the time we're done here, you'll understand why the promotional materials keep it in 4-point font. Interstellar distances don't work like the movies suggest, and they don't even work like the optimistic NASA animations suggest. Proxima Centauri sits 4.24 light-years away, making it our nearest stellar neighbor. Voyager 1's current velocity would get you there in 73,000 years. The Parker Solar Probe holds the record for fastest human-made object at 700,000 kilometers per hour, and even that speed means a 6,300-year journey. Here's the kicker: those are the close stars. TRAPPIST-1 contains 7 potentially habitable planets, and recruitment videos love showing artist renderings of those worlds with their red dwarf sunsets and alien oceans. What they skip is that TRAPPIST-1 sits 39.6 light-years away, 10% light speed, which represents technology we cannot currently build, gets you there in 400 years. 5% light speed, which also represents technology we cannot currently build, stretches that journey to 800 years. Let me put that timeline in perspective. 400 years ago, Shakespeare was still writing plays. 800 years ago, Genghis Khan was conquering Asia. A social structure needs to remain stable across that kind of historical distance while sealed inside a metal cylinder with no outside contact and no possibility of rescue. And here's what mission planners don't advertise. No period in human history lasting 250 years has avoided major wars. Generation ships require beating those odds by a factor of 2. The fine print gets worse from here. Right about now, some of you are thinking about the science. Fascinating problem, you're thinking. Surely we can engineer around the distance issue with more efficient engines, better life support, maybe some hibernation technology. What I need to introduce you to is a problem that engineering cannot solve. Maintaining genetic diversity across 15 generations requires a specific number of people, and the research on minimum viable populations should make you deeply uncomfortable. Dr. Frederick Marin ran Monte Carlo simulations, calculating that 98 people could theoretically propagate the species over a multi-century journey. That number comes with a footnote the size of a doctoral thesis. Strict genetic management must keep inbreeding coefficients below 5%, which means controlled breeding programs, which means someone decides who reproduces with whom for 400 years. You see where this is going. Anthropologist Cameron Smith examined the same problem from a demographic angle and recommended 10,000 to 40,000 people to survive catastrophes and disease outbreaks. His math accounts for effective population size, meaning the number of individuals actually contributing genes to the next generation, which runs significantly lower than your total headcount suggests. Here's a historical comparison that should concern you. Iceland was founded roughly 1,100 years ago by approximately 10,000 settlers, and modern Icelanders now carry one of the least genetically diverse profiles in Europe. That outcome happened with a population that could still receive occasional new arrivals, that experienced some emigration, and that had access to outside medical knowledge when genetic diseases surfaced. Your ship receives no new arrivals. Nobody leaves. The gene pool at launch is the gene pool you're stuck with for 4 centuries. And this is where the fine print turns genuinely ugly. Genetic diversity without reproductive control requires starting populations of 40,000 or more. Genetic diversity with reproductive control drops that number, but creates a situation where Mission Command dictates who can and cannot have children, for 15 generations, without exception. Population control notoriously and historically leads to terrible practices, as researcher Erika Nesvold points out. Post-World War I, France and Russia didn't just outlaw abortion, they outlawed contraception, and they outlawed discussing contraception in public. What you're designing is a society that manages reproduction for 400 years without becoming a eugenics nightmare, and no human civilization has ever accomplished that. But let's assume you solve that problem. Let's assume the breeding program works perfectly, and everyone cooperates, and nobody rebels against having reproductive choices dictated by an algorithm optimizing for genetic diversity. You still have to keep everyone alive. And that's where the next problem starts. Please consider liking and subscribing. I spent a ton of time researching this topic for you, and I'd appreciate your support greatly. Thanks a lot. Every generation ship concept assumes closed-loop life support, a sealed ecosystem recycling everything indefinitely. Promotional materials show lush gardens and crystal-clear water features, and air that smells like mountain forests. Here's what actual research demonstrates. Biosphere 2 costs somewhere between $150 and $200 million and remains the largest closed ecological system ever constructed, covering 3.14 acres under glass in the Arizona desert. 8 crew members spent 2 years inside during the first mission, and what they produced was the most important data in closed ecosystem research. Almost none of it was good. Oxygen levels dropped from 21% down to 14.5%, equivalent to trying to breathe at 15,000 feet altitude, and the crew required emergency oxygen injection just to survive. Carbon dioxide reacted with calcium hydroxide in the concrete walls, trapping it as calcium carbonate where nobody could extract it. 19 of 25 small vertebrates died over those 2 years. Every pollinator species went extinct inside the dome. Cockroach and crazy ant populations exploded, while beneficial insects vanished entirely. And here's the number that should terrify anyone planning a 400-year mission. The atmosphere leaked at approximately 10% per year. That leakage rate amounts to a rounding error for a 2-year experiment on Earth. That same rate becomes an extinction event for a journey through interstellar void. The Russian BIOS 3 facility achieved 90 to 95% closure for air, water, and waste recycling, and their longest successful run lasted 180 days, with 3 people inside. The European Space Agency's Melissa project has been developing closed-loop life support since 1989, and it remains in the pilot phase at a Barcelona university, having never achieved full closure. No closed ecological life support system has ever achieved long-term stability. The longest successful test ran 6 months. Generation ships require missions 800 times longer than that. The fine print is simple. The technology doesn't exist, has never existed, and nobody knows whether it can exist. But let's keep assuming. Let's say you solve life support too, achieving perfect recycling and stable ecosystems and clean air forever. Now we need to talk about what happens to the people breathing that air. The Mars 500 experiment locked 6 people inside a simulated habitat for 520 days to replicate a Mars mission timeline. 4 of those 6 developed significant sleep disorders. Crew mood crashed around the 75% mark of the mission. Blood tests showed serotonin and dopamine levels physically declining over time from isolation and confinement alone. Those participants knew they were going home. Generation ship passengers face something entirely different, and this is where I need you to pay close attention, because this is the part mission planners genuinely don't know how to solve. The University of Warwick identified the core problem with unusual clarity. First-generation crew may be dedicated, may have spent years training and preparing, may genuinely believe in the mission and its purpose. Children born on the ship have a very different upbringing and no realistic choice other than to follow their parents' vocation for their entire lives. Philosophers call this the middle generation problem. I call it the prison ship problem. Nobody has solved it because nobody has experienced it and survived to report back. Founding generation crew members get departure glory and historical significance, and an Earth they can remember and mourn. Final generation crew members get arrival triumph and new worlds, and the payoff for everything their ancestors sacrificed. The 8 to 12 generations between those bookends get nothing at all. They never witness departure, they never witness arrival. Their entire existence is the journey itself, a metal cylinder they didn't choose, surrounded by people they didn't pick, performing jobs that must be done because the alternative is everyone aboard dying. Here's the thought experiment that keeps ethicists awake at night. Every human who has ever lived possessed more freedom than these people will. Philosopher Neil Levy states the dilemma in plain terms. Adults can and do leave Amish communities when they choose to. Nobody gets to leave the generation ship. High Seas 4 locked 6 people inside a 1,300 square foot dome in Hawaii for 366 days. And principal investigator Kim Binstead observed something she named microstimuli growing macro. Small irritations accumulated over time. Things like how a crewmate clears their throat, the sound someone makes while chewing food, the particular timbre of their laugh. These minor annoyances transformed into major conflict sources as months passed. Your ship carries 10,000 people who will hear each other's breathing and chewing and laughing for their entire lives, then pass those irritations down to children who inherit the grudges, along with the confined spaces and the complete inability to ever walk away from any of it. That inheritance continues for 400 years. And we haven't even discussed whether you possess the right to create these people in the first place. Some of you are thinking this through logically now. Acceptable losses, you're calculating. Necessary sacrifice for the survival of the species. The needs of the many outweighing the needs of the few. What I need to introduce you to is a philosophical problem that doesn't have a solution, and likely never will. Every child born on a generation ship arrives in circumstances they never chose and cannot escape from. Philosopher Joel Feinberg's work on children's rights argues that children possess autonomy rights held in trust, meaning rights they cannot exercise yet, but that adults cannot violate on their behalf. Ship-born children have this right violated before they take their first breath. The Electric Athenium describes what they face as lifelong imprisonment in a metal box without hope of reprieve. First-generation astronauts volunteer for their fate and accept those consequences willingly. What they also do is condemn their children and their children's children to that same fate without any form of consent. Some researchers argue that Earth itself functions as a generation ship because we all inherit circumstances we didn't choose, and constraint defines the universal human condition. A child born into poverty in Bangladesh didn't select their circumstances either. Here's why that argument collapses under examination. The Bangladesh child exists within a system that, at least theoretically, allows mobility, change, and escape from those initial conditions. Generation ship children have none of those options available to them. The walls are absolute and cannot be breached. The destination is fixed and cannot be altered. The journey cannot be shortened, cannot be abandoned, cannot be refused by anyone aboard. No exit exists. Not for them, not for their children, not for anyone until arrival, assuming the ship even makes it that far. And that's the fine print nobody wants to read aloud. That's the reality of generation ships laid bare. You board a vessel carrying 10,000 people toward a star that your descendants might reach in 400 years, assuming the life support holds steady, assuming the population genetics work as modeled, assuming the social structure survives longer than any human civilization ever has, assuming the ecosystem achieves stability that no experiment has demonstrated, assuming 15 generations of people accept imprisonment for a destination they'll never witness with their own eyes. The TED Talks jump straight from identifying habitable exoplanets to proclaiming humanity's destiny among the stars. The gap between those statements contains every problem that actually matters, including the breeding programs and the ecosystem failures and the psychological collapse and the ethical catastrophe of creating humans who exist solely to maintain a ship they cannot leave. Nobody renders the child born in Generation 7 who dreams of becoming a marine biologist on a vessel containing no ocean. Nobody animates the teenager asking why they must spend their entire life maintaining oxygen scrubbers for people who won't be born for another 2 centuries. Nobody depicts the middle generations slowly realizing that their existence serves as a means to an end they will never witness. That's the fine print on generation ships, everything the promotional materials skip when discussing humanity's future among the stars. Technical challenges might yield to enough engineering talent and enough development time. Human challenges don't have solutions because humans weren't designed for this kind of existence. Redesigning humans to tolerate such conditions raises questions that make the engineering look simple by comparison. You can build the ship, you can load the colonists, you can fire the engines and aim for distant stars. But somewhere around Generation 4, the people aboard will have become so different from you, so thoroughly shaped by their metal world and recycled air and enforced proximity, that calling them your descendants becomes a purely biological designation. They might worship you as gods who granted them existence. They might despise you as jailers who handed them a sentence they cannot appeal. What they will almost certainly do is forget you entirely. Colonization pitches show the destination in vivid detail. The fine print covers the 400 years between here and there. What's the next cosmic death sentence you want the fine print on? I hear Europa's subsurface ocean features some interesting pressure dynamics, and the tourism brochures definitely won't mention what happens to human bodies at 1,000 atmospheres.